In this third question, I have to find the value of k for which x minus 1 is a factor of px in each of these given cases. So basically x minus 1 will be a factor of px if p1 is equal to 0. So this is what I have to, this condition is what I have to apply in each case and hence determine the value of k. So let's do it for the first polynomial. So the first polynomial is px is x square plus x plus k. So that means that p of 1 will be equal to 1 square plus 1 plus k, which is 2 plus k. Now this should be equal to 0 because x minus 1 is a factor of px. Hence by the factor theorem p of 1 needs to be 0. So 2 plus k is equal to 0, which means that k has to be equal to minus 2. So that's the value of k in the first part. In the second part, let's calculate p of 1 again. So p of 1 in the second case will be obtained by substituting x equal to 1 into the second polynomial, 2x square plus kx plus root 2. So that is equal to 2 times 1 square plus k times 1 plus root 2. So this is equal to 2 plus k plus root 2, and again this has to be equal to 0, which means that k in this case will be minus 2 minus root 2. So this is the value of k in the second part for x minus 1 to be a factor of px. Now let's go to the third part. In the third part, p of x is this polynomial kx square minus root 2x plus 1. So let's find p of 1. So p of 1 will be k times 1 square minus root 2 times 1 plus 1, which is equal to k minus root 2 plus 1. So again this should be equal to 0, which means that k should be equal to root 2 minus 1. So this is the value of k for the third polynomial if x minus 1 has to be a factor of px. Now let's go to the fourth part. In the fourth part, px is kx square minus 3x plus k. So p of 1 will be equal to k times 1 square minus 3 times 1 plus k. So this is equal to k minus 3 plus k, or this is equal to 2k minus 3. Now again this needs to be equal to 0, which means that k has to be equal to 3 by 2 for x minus 1 to be a factor of px in this case. So this solves question 3 of the exercise. Now let's go to question 4. In the fourth question, I have to factorize these 4 polynomials and all of them are quadratic polynomials. So the approach I'm going to take is to split the middle term. So let's start with the first part. So in the first part, the polynomial is 12x square minus 7x plus 1. So the middle term is minus 7x. The middle coefficient is minus 7. So I have to find out two numbers whose sum is minus 7 and whose product is 12 into 1 or 12. And if you think about it, those two numbers are minus 3 and minus 4. So that's how I can split the middle term minus 7x as minus 3x minus 4x. So let's do that. So this will become 12x square minus 3x minus 4x plus 1. Now from the first pair of terms, I can take out a factor of 3x common. So that leaves me with 4x minus 1. And from the second, I can take out a factor of, actually there's no common factor. So I can just write this as minus 1 times 4x minus 1. And now I have this 4x minus term as common. So I take it out and I'm left with 3x minus 1 times 4x minus 1. So this is the factored form of the first polynomial. Now let's go to the second one. The second polynomial is 2x square plus 7x plus 3. So this time I have to find out two numbers whose sum is equal to 7 and whose product is equal to 2 times 3 or 6. And those two numbers, if you think about it, are 6 and 1. So that's how I can split the middle term. So I can split it as 2x square plus 6x plus x plus 3. Now from the first pair, I can take out 2x common. So that gives me 2x times x plus 3. And the second term is itself x plus 3. So I can write this as 1 times x plus 3. And now I can take out x plus 3 common. So I'm left with 2x plus 1 times x plus 3. So this is the factored form of the second polynomial. Now let's look at the third one. The third one is 6x square plus 5x minus 6. So in this time I have to find two numbers whose sum is equal to 5 and whose product is equal to 6 times minus 6 or minus 36. So 36 has factors like 2, 3, 4, 6, 9, 12 and so on, and you have to find out two factors whose sum is equal to 5 and product is equal to minus 36. So those two factors will be some combination of 9 and 4, because the difference of 9 and 4 is 5. So I can actually take 9 and minus 4. So the product of 9 and minus 4 is minus 36 and the sum is 5. So this is how I can split 5x this time as 9x minus 4x. So my polynomial becomes 6x square plus 9x minus 4x minus 6. So from the first pair of terms, I can take out a common factor of 3x, and that leaves me with 2x plus 3. And from the second pair of terms, I can take out minus 2 common, and that leaves me with 2x plus 3 again. And now I have 2x plus 3 common, so I can take that out, and then I get 3x minus 2 times 2x plus 3. So this is the factored form of the third polynomial. Now let's do the fourth one. So the fourth polynomial is 3x square minus x minus 4. So this time I have to find two numbers whose sum is minus 1, the coefficient of x, and whose product is 3 times minus 4, which is minus 12. So the answer is right there in front of you. The two such numbers are 3 and minus 4. Their sum is minus 1 and their product is minus 12. So that's how we can split the middle term this time, minus x as 3x minus 4x. So let's do that. So I'm left with 3x square plus 3x minus 4x minus 4. So from the first pair, I can take out 3x common, so 3x, and that leaves me with x plus 1. And from the second pair, I can take out minus 4 common, so minus 4 times x plus 1. And this time I have x plus 1 common, so I take that out, and I'm left with 3x minus 4 times x plus 1. So this is the factored form of the fourth polynomial, and that completes question number 4.
Hi students, being good at math is super important because it helps you do well at school, but more importantly, it opens the doors for you to the most awesome careers of the future. Having taught thousands of students, I can confidently say that every student can really excel at math, including you. So I've created something special to help you become a master of math. Go to qmat.com/leap to find out more. I'll see you there.